So this lecture is on the second sections of chapter 3. We'll discuss about the rules of differentiations. So in the first sections of chapter 3, we learn about how to find the derivative of the function using the limit process. And then using the limit process, we'll come up with rules that can help us find the derivative of any of the functions. All right, let's start with the constant rule. So the constant rule says the derivative of a constant should be 0. And if you look at the graph on the left side here, you can see that if you have a horizontal line, right, and then the horizontal line is not changing, the y values of horizontal line is not changing when x change. That's why the slope of the horizontal lines is 0. That's why the derivative of the constants functions should also be 0. Okay, and how can you show that? You can show that using the proof, right? You can prove using the limit definitions of the derivative. So you plug the constant functions into the limit definitions. The limits of delta x go to 0 of f of x plus delta x minus f of x divided by delta x. So that's the definitions of the derivative. And then you can evaluate the this limit, and the results is going to be just 0. So the derivative of a constant is 0. And the next rule is about the constant multiple rule. So what is a constant multiple rule? It's saying that if function f is differentiable functions and c is a real number, then when you multiply a real number to a functions and you differentiate it, it's the same as you take c and you multiply to the differentiations of f of x, c times f prime of x. Sorry. And again, you can prove it using the limit process. And also another thing that you want to pay attention is c, if we have c as a constant, that means you just need to move it out of the functions in front of the derivative, and then you can find the derivative of the function of f of x, and you just multiply to the c. Okay, this is a constant multiple rule. And the next rule is a power rule. The power rule says if n is a rational number, and then the power functions x to the n is differentiable, and the derivative of x to the n equals to n times x to the n minus 1. Another way to visualize this rule is if you want to take the derivative of x to the n when n is rational, then you just move the n, the power n, into the front of x, and then you subtract 1 from the power, you get n minus 1. And again, in order to prove this rule, right, you just put the functions x plus delta x to the n into the limit definitions of the derivative using limit process. And then you evaluate the limit and you get to the answer. But keep in mind that in order to evaluate these limits, you need to review yourself of the procedures for expanding a binomial. So if you look at the top of the page here, you have x plus delta x squared would be x squared plus 2x delta x per delta x squared. And you have x plus delta x cubed, and so on and so forth. So for the power of n, in general, the binomial expansions for a positive integer n is going to be x to the n plus n, x to the n minus 1 delta x plus n, and so on and so forth, right? And this, you can see that you have delta x terms in most of the term except the first term. So then when you bring it down to the proof, you can see that x to the n will get canceled by the x to the n at the end of the numerator. So then you have all the terms left in the numerator have delta x. That's why you can cancel the delta x in the denominator. And then once after that step, you can just plug 0 into plug 0 into the functions to get the limit. And the result is going to be n times x to the n minus 1 will be the derivative of x to the n. Right, and you can see here, here's the three, in our lecture note, here's the three rules that we just talked about. So the constant rule, the derivative of any of the constants should be 0, okay? And then the constant multiple rules, if you have c multiplied to x and you want to find the derivative of c times f of x, you just move the c out in the front, and then you multiply c to the derivative of f of x. So this is the simple example of that rule. If you know that the derivative of f of x is 2, right, then the derivative of 3 times f of x is the same as 3 times the derivative of f of x equals to 6. That is how you use the constant multiple rule to find the derivative. And next to the power rules, we know that the derivative of x to the n equals to n times x to the n minus 1. Okay, and for n be a rational number. Then we can try to do an example. So the next example is if you're given the function f of x equals x cubed, then you want to find f prime of x equals to what? So this is x to the n when n equals 3. So you would move 3 to the front, multiply to x, and you subtract 1 from the power. So the answer is 3x squared. Okay. For this functions, n now is 2 over 3. So then f prime of x is, it's going to be 2 over 3 times x, 2 over 3 minus 1, which is 2 over 3, times x negative 1 over 3, right? And keep in mind that x to the negative 1 over 3 is the same as 1 over x 1 over 3 if you bring it down to the denominator. So you squish the sign. And at this point, you want to notice that the functions f of x is defined, right, when x equals to 0. But f prime of x is not defined when x equals to 0, because you have x to the 1/3 in the denominator. So this means f of x is not differentiable at x equals to 0. Okay, so if f prime of x is not defined at a point, that means the functions f of x is not differentiable at the same point. Now let's talk about the sum and the difference rules. So the sum and the difference rule says that if you add two functions and or you subtract the two functions, and if those functions are differentiable at a point, then the derivative of the sum of the two functions equals to the sum of the derivative of those functions. So that if you have f of x and g of x are the two functions that is differentiable itself, then the derivative of f of x plus g of x is the same as f prime of x plus g prime of x, that's the sum rule. Similarly, for the difference rule, the derivative of f of x minus g of x equals to f prime of x minus g of x. And again, you can show these rules using the limit process, the definitions of the functions. And at the end, and then in this case, you add f of x and g of x, and you put it in the definitions of the limits of the derivative, right? And then you evaluate this definition, this limit, in terms of f of x and g of x. And then at the end, you will get the derivative of f of x plus g of x equals to f prime of x plus g prime of x. And it also applies to the difference between f of x and g of x. And then one thing to notice is the sum and the difference rules can be extended to any finite number of functions. For example, if you have three functions, f of x plus g of x minus h of x, then the derivative of that combination is going to be just f prime of x plus g prime of x minus h prime of x. You can extend the number of the functions extend the number of the functions infinitely. All right. And we talked about the sum and the difference rules. Now we can start doing some examples that involves multiple rules here. So let's look at the first problem in example number 4. So you have a function f of x. It's a combination of the three functions, right? You have, this is power functions, this is another power functions, and this is the constants functions. Then what is the derivative of these functions here? So you can use the difference and the sum rules to find. So f prime of x here, right, equals to the derivative of x cubed minus the derivative of 3x squared plus the derivative of 1. So this is a polynomial, right? You have a power here. You can use the power rule. The power rule say that you can move 3 to the front x, and then 3 minus 1 should be 2. Minus, this is also power rule can be used here. You have 3, right, times 2. You move the 2 down here, x to the 2 minus 1, which is just 1. So x to the 1, which is x. So in this function, you use power rule, and also you use the constant multiple rule here. And go to the last one. What is the derivative of the constants? It should be just 0. So the final answer for this function, the derivative of this function is 3x squared minus 6x is your final answer. Go to the next questions. So you have a function, it's the rational functions, and you have a divisions here, right? But we haven't learned about the products or the quotient rule yet. But then one thing that we can do is we can simplify this function. So first I want to simplify these functions by take the numerator, split the numerator into 3 different functions, and then I take each numerator divided by the denominator, minus 7x divided by x plus 2 divided by x. Okay, so then I can simplify each of these functions. So x squared, x, so the 2 gone, x gone, x gone, and then 2 over x. And 2 over x, I would just, so it's just going to be 3x minus 7 And 2 over x, I will convert it to a power functions. All right. So 2 over x equals 2 times x to the -1. Okay, you bring it up to change. You just change the sign of a power when you bring it up. So now to find the derivative of this functions here, f prime of x equals to, I want to use this simplified versions, d over dx of 3x minus d over dx of 7 plus d over dx of 2 times x to the -1. Okay, so the derivative of 3x, you're going to use the constant rule, the constant multiple rule, and also the power rule. So it's going to be just 3 times, what is the derivative of x? The derivative of x should be just 1, right? Times x to the 1 minus 1, which is just x to the 0, should give you 1. And minus derivative of the constant should be 0, plus the derivative of 2, right? You use a constant multiple rule, 2 times x. This is a power, so you bring the power down, and x to the -1 minus 1. Okay, so 3 times x to the 0, which is 1, so it's going to be 3 minus 0 plus 2 times -1 is -2, x -1 minus 1 is going to be -2. So this is going to be your final answer. Or if you want to bring the -2 down to the bottom to make it positive, it can be written this way, equals 3 minus 2 over x squared. Okay, these both are a correct answer. They're just written in different forms. Next, I want to introduce the derivatives of some basic functions. So the first two functions I want to talk about the sine and cosine functions. So the derivative of sine function is cosine, and the derivative of cosine is negative sine. And the proof of the first of the derivative of sine equals cosine is given here. So you just use the limit process again, right? Plug sine of x plus delta x minus sine over delta x. Take the limit of this when delta x goes to 0. And then you're gonna manipulate some of the trigonometry rules in order to split this whole thing here into two different functions like this. And the answer is the derivative, the limit when delta x go to 0. For this part, it is cosine of 1. Remember this, one of the special limits that we learned earlier. And if you plug delta x go to 0, this is also another special limit, the second special limit that we learned. So from these two special limits, we can conclude that the derivative of sine equals cosine. And you can use the same process to show that the derivative of cosine equals to the negative sine, using the very, very similar process to show these two rules. Remember, the derivative of sine is cosine, and the derivative of cosine is negative sine. All right, next, the derivative of exponential functions, let's say e to the x. And again, you want to find the derivative of e to the x, you have to plug it in the limit process, right? The definition of the derivative, and you can evaluate it until the point when you have this limits here. And again, at this point, you still cannot plug 0 into delta x, but you remember there's a definitions of e is an Euler number, right? It's 2.71 and so on and so forth. And this is the definition of e, the limit of delta x goes to 0 of 1 plus delta x raised to the 1 over delta x. So then you can see that in very small values of delta x, you have e is similar to 1 over delta x over 1 over delta x, which is implied that e to the delta x is the same as 1 plus delta x. So you replace e to the delta x equals to 1 plus delta x here. So then you can replace this back into the limits that we have here, right? So to have e to the x1 plus delta x. And then you can simplify this function down to e to the delta x times e to the x times delta x over delta x, and which will show you that the derivative of e to the x is itself. This is one of the very nice functions which tells you that the rate of change of the functions here is the same as the function value. So the derivative of e to the x is just e to the x. So here's a table of the derivatives of some basic functions, right? We just talk about cosine of x. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of e to the x is e to the x. Derivative of ln x is 1 over x. Derivative of square root of x is 1 over 2 square root of x. Derivative of log base a of x equals 1 over natural log of a times x. And the derivative of a to the x equals natural log of a times a to the x. All right, these are the derivative of some basic functions that you can see it clearly here. All right, so now we can start doing more examples on how to find derivative of a little more complicated functions. Okay, so first we have f of x equals to x plus 2 cosine x. So that means the derivative of f of x, f prime of x equals to derivative of x plus derivative of 2 cosine x. Okay, and what is the derivative of x? 1, right? As we learned earlier, derivatives, you can use the power rule to find the derivative of x, in which is just 1. 1 times x to the 0 is 1, plus 2 times the derivative of cosine of x. We use constant multiple rule here. We move the 2 out in the front. And what is the derivative of cosine of x? Remember, the derivative of cosine of x is negative sine of x. So it's going to be 2 plus 2 negative sine of x, which is just 1 minus 2 sine of x. Go to the second functions. F of x equals 2 e to the x minus pi over 3 cosine of x, right? So what is a derivative of x? What is f prime of x? So again, you're going to use 2, right? Derivative of 2 e to the x minus the derivative of pi over 3 cosine of x. You're using the difference rule here. So, and then you're going to use the constant multiple rule. You move the 2 out, and then the derivative of e to the x is just e to the x, right? And then again, and also pi over 3 is just a constant. Move it out. And the derivative of cosine of x, which will give you 2. Derivative e to the x is easy, e to the x minus pi over 3 times what is the derivative of cosine of x? Again, negative sine of x. So then the final answer should be 2 e to the x plus pi over 3 sine of x. Alrighty, next problem. So you have a little more complicated functions here, right? E to the 3x over e to the 2x plus natural log of e3 over x. And again, we only learn about the derivative of these basic functions. When basic functions mean when the functions, the input of all of this function is just x. And you can see that is just e to the x sine of x, right? Cosine of x, and so on and so forth. But when you have the functions, when the input is not x anymore, it's 3x, then you cannot use the basic function. For example, the derivative of, for example, d over dx of e to the 3x is not e to the 3x. Okay. We know that the derivative of e to the x is e to the x, but this is not true. One thing that this is not true. Another thing is, and again, derivative of natural log of 3 over x is not 1 over 3 over x, even though the derivative of the ln x equals 1 over x. Keep it in mind. So when the input is not x, then you cannot use the symbol, the basic functions to find the derivative. Okay. Yet we have, in these cases, later on we can use chain rule to find the derivative of this complicated function, composes function. But now what we can do is we can simplify this function first. So what is e to the 3x? What is a to the b over a to the c? It should be a to the b minus c, right? So then you can apply that rule to these functions here. It's going to be e to the 3x minus 2x, right? Plus, how can simplify this natural log of x? So remember, natural log of a over b is the same as natural log of a minus natural log of b. Okay, so then this is going to be equal to natural log of 3 minus natural log of x. All right, from here, then we can find the derivative of f of x. F prime of x equals to the derivative of e to the x, because 3x minus 2x is e to the x. Okay, plus the derivative of natural log of 3 minus the derivative of natural log of x. Okay, so we know that the derivative of e to the x is just e to the x. Natural log of 3 is just a constant. Then this derivative will be just 0. And the derivative of natural log of x is 1 over x. So the final answer is e to the x plus 1 over x. So this is the section 3.2 in your textbook. It shows some basic rules of the differentiations. The rules that you can use, some basic rules that you can use to find the derivative of functions, right? Of any functions. So you learn about constant rule, constant multiple rule, power rule, and you learn how to find the derivative of some of the basic functions here, right? And then you learn how to maybe manipulate all the rules in order to find the derivative of some of the basic or a little more complicated than the basics functions here.